Hi, you're right. Today we're going to look at solving equations with fractions. So, first thing to note is we're going to look at two types, and we have seen this before, but I think it's definitely worth going over again. One type is the uh, where the fraction is created where it's just over the variable, so just over the letter. So here we've got x over 5 add 2. Notice the difference between this then, where the fraction is created and it's over the whole of the left hand side. So in one type, which is the first type I'll go through, the fraction is just over one of the just over the variable. In the other type, it's over the whole of the left hand side, or equally it could have been over the whole of the right hand side. That says the same thing. So don't be put off by seeing it all on one side, or all on the left hand side, or all on the right hand side. We need to be used to seeing different scenarios. So you can just get those down as type 1 and type 2, and just some brief notes about what I've said there. And first works example we're going to do is, or rather I'm going to run through this one, then I'll give you your turn. You should be in the hang of it by now. Copy out the work example, have a go at your turn, and then mark it. So first question. So you can just get it down in your book, and then I'll go through it now without talking, and then I'll annotate it and talk through what I've done. And there's my final answer, W equals 21. Notice my first step was to just try and get this W over 3 on its own. So I did the inverse of taking away 5. So added 5 to both sides to keep it balanced. So that got me to just W over 3 equals 7, because 2 plus 5 is 7. Then notice the inverse of dividing by 3 times in by 3, so that got me W on its own. Now, you may think, well, why don't I times by 3 first? Which you could do, but I think it's harder because. So I'll just show you the other way you can do it and still get the right answer. Start by timesing by 3, but if you times by 3, then that's like it's like when we expand brackets, you'd have to times everything on the left hand side by 3, and we'd have to times that by 3 as well. So then I'd need to do, well, sorry, I've written 5 there, haven't I? W over 3. That would just get me W, and then I'd get 15 here, and then I'd get 6 here. So I think the step that you would forget if you thought times by 3, the mistake that people make if they start by timesing by 3 is, rather than putting minus 15, they'll go, right, let's times everything on the left hand side by 3 and everything on the right by 3, and then I get W minus 5 equals 6. Well, what mistake has been made there? I haven't times that 5 by 3 as well. So because remember with expanding brackets, we need to times everything by 3. So if we times everything on this left hand side by 3, this would no longer be a 5, it would be a 15. But the easy way around that is to just add 5 on first and then times by 3. So if you feel like you're someone that's going to make that mistake, then maybe just get that down and just put it down as a non-example in your book. I'm just going to rub it out now so I've got a bit more space. So you may need to go back and pause the video if you missed if you didn't get any of that down. Right, the your turn one I'd like you to have a go at. Let's change over sides actually, just so you get used to. So let's reflect expect checks. All that's changed is we've got a 2W now over 3, and it's just moved from left hand side to right hand side. That shouldn't affect what you do. So have a go at that question, pause the video, and now I'll go through it. And I'll even include the arrows sometimes for this time for the people that like it. So I'm going to add 5 to both sides, start the same. I'm going to times by 3 because that is the inverse of dividing by 3. And now I'm going to divide by 2 because that's the inverse of timesing by 2. So that is 10.5 equals W. Notice that from here to here, our answer is halved. That's because we've now got 2W instead of just W. Right, so there's your example of the first type where the fraction is just over the variable. Now we're going to look at the second type. So worked example in your turn. I will go through this one in silence first of all, and then you can have a go at the one on the right, which I'll give you in a second. So I've got x equals 7. I can double check that by subbing it back into here. 2 times 7 is 14, add 1 is 15, divided by 3 is 5. So yeah, I've got that right. Let's just talk through what I did there. Notice this time, when it's over the whole left-hand side, I can times the whole left-hand side by 3, and that will get rid of it because it's the inverse of dividing by timesing by 3 is the inverse of dividing by 3. So I've times both sides by 3, and then that will get me 15 on the right hand side and just 2x plus 1 on the left hand side. So then from there, I've taken away 1, inverse of adding 1, divided by 2, inverse of timesing by 2, and then I get my answer of x equals minus 7. X equals 7, sorry. Now you may think, well, last time I did an addition as my first step, not a multiplication. So let's just see why that's not the case in this example. And to do that, I'm just going to write this as 2 separate fractions. Remember, when I've got the same denominator, that just means I can split up that fraction to be 2 fractions that looks like that. Well, if I chose to, let's say my first step, I took away 1 from both sides, well, that would get me 2x over 3 equals 4. Well, you might think it would get you that. But actually, we can see from the thing I've drawn out here that we're not taking away 1 from both sides. We'd have to take away 1/3 from both sides, which isn't, it's not really that easy to do. So we want to make our lives nice and easy. Because now look, I'm getting fraction on the right hand side, still got a fraction on the left, and it just becomes tricky to deal with. So I can't take away 1 because it's not just 1 that I'm looking at, it's 1 over 3, and I don't really want to split it up and then take away 1/3, which is what would work and you would get to the right answer, because I end up with fractions and it just gets really tricky. So the first easiest step to do is times both sides by 3. And I'll just show an example of why timesing by 3 works, because if we're timesing this side by 3, that's like saying that, because remember, timesing by 3 is like expanding a bracket here. Well, I can see that the 3's will cancel out because 3 divided by 3 is 1. So that's like saying I've got one lot of 2x plus 1 left now, which is what I get on my left hand side in my next bit of working. Right, last question for you to have a go at. I won't switch it around this time, I'll just change the numbers a bit. So maybe try and make a prediction about what you think is going to happen based on expecting from left to right. Pause the video, have a go at it, and now mark your work in red pen. So first step, I'm going to times by 3. take away 1, divide by 4. And I should get 14 over 4, which I can simplify to 7 over 2, because I've just divided top and bottom by 2, which is 3.5. So how does this answer compare to this answer? Well, it's half, because I've got double the amount of x's on top. But don't worry too much about the reflect, expect, check. It was just an additional thing you could do. Okay, if you have any problems with any of that from today, then please email me. Any support, feel free to email me. I'm more than happy to help you. I will be setting a task for, I think it's Wednesday is our next lesson, or maybe Tuesday, whenever it is, either on diagnostic questions, probably on diagnostic questions actually. So if you haven't signed up to that, then make sure you have. Have a great rest of your day.